Welcome back, everybody. We are up to the beginning of Unit 4, Lesson 1. This particular unit, the first half of this unit, will actually be the last unit of Algebra 2A. Once you are done with the mid-unit test for this unit, you will be done with Algebra 2A, with Semester 1 of Algebra 2. And what the first half of this unit focuses primarily on is exponential growth and decay. What we have right here on your screen in your lesson notes, this is basically your lesson notes for the entire half of this unit. There will not be any different lesson notes at all moving forward until we get to past the mid-unit tests. As you can see here, your exponential growth and decay formula, your basic formula is here. Y equals A times B to the power of X. A is your initial value, and B is your growth or your decay factor. So your growth or decay factor will depend on what type of situation it is. If it is an exponential growth situation, your growth factor will be greater than 1. If it's an exponential decay situation, then your decay factor will be less than 1. Okay? Very often when we're talking about exponential growth and decay, we're talking about things going up or down by a percentage. So if your growth or decay factor involves a percentage, okay, to find if it's an exponential growth situation and you're going up by a percentage, you find the growth factor by doing 1 plus the percentage. So an example would be if you're growing, say, by 5%. 5% we know as a decimal is 0.05. So the growth factor would be 1 plus 0.05 or 1.05. If it were going down by 5%, so if it were an exponential decay situation, your decay factor would be 1 minus 5% or 1 minus 0.05, which is 0.95. So that depends on whether it's a growth or a decay factor. Will depend on whether you add the percentage or subtract the percentage from 1. So with that in mind, let's take a look at the examples for this lesson here. So, number 1, a standard sized piece of paper has an area of 93.5 square inches. If we keep folding the piece of paper into quarters, find the area of the paper after 3 rounds of folding. So, we're going to use our formula here. Okay. So our A value is your initial value. So in this case, what is the initial area of the piece of paper? That would be 93.5. And your B value is your growth or decay factor. In this case, we're folding the piece of paper into quarters, which means the paper is getting smaller. So it's going to be a decay factor. It's going to be a decay factor, which means it's got to be less than 1. So the key in this case is that we're folding the piece of paper into quarters. So quarters implies that my decay factor is going to be 1/4 or 0.25. So the fact that we're folding the piece of paper into quarters implies that the decay factor is 1/4 or 0.25. And then your X value, find the area of the paper after 3 rounds of folding. So my X value is going to be 3. So to figure out the answer, I need to calculate 93.5 times 1/4 to the power of 3. So I'm just going to go into Desmos to do that. So 93.5 times 1/4 to the power of 3. And there is your answer. So I'm going to round this to 2 decimal places. So the answer will be 1.46. So my answer for number 1 is 1.46 square inches. Number 2. The value of an account in 1970 is $125. If the value grows exponentially at a rate of 5% per year, find the value of the account in 2020. So the value of an account in 1970 is $125. So that tells me when I use my formula that 125 is going to be my initial value. The value is growing at a rate of 5% per year. So we're looking for a growth factor in which we're going up by 5% each time. So let's go back to the lesson notes. Okay. So when we are going up by a percentage, my growth factor is 1 plus the percentage. So I'm going up by 5%. So 5% is 0.05. So 1 plus 0.05 is my growth factor. So that would be 1.05. So my B value in this case is going to be 1.05 for the reasons that I just stated. Find the value of the account in 2020. So 2020 is how many years later? Well, it was $125 in 1970. So 1970 to 2020 is 50 years. So my X value is going to be 50 years. So to find the value of the account in 2020, I need to calculate 125 times 1.05 to the power of 50. So let's go to Desmos. So 125 times 1.05 to the power of 50. And since we're talking about money, I'm going to round to 2 decimal places. So this would be $1,433.42. So $1,433.42. So that is the value of the account 50 years later. Number 3, the length of a photo is 150 millimeters. If we keep decreasing the size of the photo by 20%, find the length of the photo after 2 rounds of decreasing the size by 20%. So, once again, we're using our formula. All right, my original length is going to be 150. Okay. We're decreasing the size of the photo by 20%. So finding the decay factor is going to be a little more difficult this time. So we're decreasing the size of the photo by 20%. If we look at the lesson notes, if I'm going down by a percentage, my decay factor is 1 minus the percentage. 1 minus the percentage. So if I'm going down by 20%, I know that 20% as a decimal is 0.2 or 0.20. So my decay factor is going to be 1 minus 0.2 or 1 minus 0.20. And 1 minus 0.2 is 0.8. So this right here is my decay factor for number 3. So that's what I'm going to plug in for B. So my B value is going to be 0.8. And then find the length of the photo after 2 rounds. So my x value is going to be 2. So I just have to calculate this. 150 times 0.8 squared. 150 times 0.8 squared. And we get an answer of 96. So that would be 96 millimeters. Okay, the key in this was finding the right decay factor, which is why I wrote this down right here. That is it for lesson 1.